Now let's look at, I know we missed example 4. Sorry about that. So now we're going to transition again to a different type of inequality solving. So this says solve 3x squared minus x minus 5 greater than or equal to 0 by graphing. So you're going to use a graphing calculator. And what we're looking for is the x interval that will show the part of the parabola that is greater than or equal to where y is 0. So you're going to use your graphing calculator, and then on the calc menu, you're going to go to number 2, 0, and find the approximate zeros of the function. So I'm going to pull up my graphing calculator and do this. All right, so we're solving the example 5 inequality using our graphing calculator. So first you want to go to your y equals menu, and then you're going to enter your quadratic. Now you're just going to have the equals here. Don't worry about the inequality. So we'll put 3x squared minus x minus 5. And be sure you use subtraction and not negative signs. Then let's graph that. So if you just go to zoom and then 6, you'll get a standard window, and so we can see our parabola here. It is opening up. Now when it asks for to solve that quadratic equation, which is greater than or equal to 0, we want to have the x intervals that show the part of the parabola that is greater than where y is 0. So that's starting right here on the x-axis is where y is 0. So it's going to be this branch right here coming up and this branch coming there. Now I want to find out what these x values are where it's crossing the x-axis. So we can let our calculator do that. So we're going to go to second calculate. So our second button and then our calc, which is above trace. And then we want to find the zeros of our parabola, which is where it's crossing the x-axis. So we'll say 2. Now it asks a question, so it wants a left boundary. So I want to find this 0 here on the left. So I'm going to put in a number for x that is clearly to the left of where that is intersecting. So I'm going to put in -2. And then I'll press enter. And then it wants a right boundary. So I need to put a number that is to the right of the intersection here, but doesn't go all the way over past the other intercept. So I'm just going to put in 0 where x is 0. There, and so now it's going to look in between those two marks and it's going to find where it's crossing the x-axis. And so it says guess, and you just press enter here. And then you'll see that our first 0 is 1.135 or approximately 1.14. Now for our next 0, we can just do the process again. So I want looking for the right intersection, so I'm going to put in 0 for my left boundary, and then I'm going to put in +2. And then I'm just going to say guess, and it is 1.4. So we have negative 1.14 and then positive 1.4. Now back on your notes paper, if you want to actually give the answer to this question, we want to give the interval for the x values that show where these ends of the graph are. So the ends of the graph that are greater than 0. So we know the points -1.14 and +1.4. So we say it's all the x values that are less than or equal to -1.14 and greater than +1.4. So let's do the next one, B. So we're going to enter our equation, which is 2x squared plus 3x minus 2. And then we can graph that. And so let's find what those intersections are, those x-intercepts. So we'll go to our second calc and then trace. So my left boundary, I'm going to put in -3, and my right boundary, I'm going to put in 0. And so for my guess, I just press enter, and I have that my 0 is -2. That's one of them. And then the next one, I'm going to do a right boundary. Or sorry, find the right x-intercept. So for my left boundary now, I'm going to put that as 0. And then for my right boundary, I'm going to say +2. And so it is at 1/2. And so then if you look at the inequality, we want the part of the parabola that is less than or equal to. So that means where y is 0. So that's going to be this lower and part of the curve, and it is over the x values that are in between these two. So our solution would be the x interval where the x's are less than or equal to 1/2 and then greater than or equal to -2. All right, so that's all of the examples I'm going to do with you on the graphing calculator. I will talk you through the other two while you are doing them on your graphing calculator. So I'm going to highlight just what we came up with when I showed you how to do this on the graphing calculator. So we put in values for the left and the right boundaries when we did the second calc, and then went to number 2 to find the zeros. And then when the question came up for the calculator to guess, you simply press enter, meaning yes, go ahead and guess. And then it tells you each of the intercepts. Well, first it will tell you the one intercept, and we know that that was actually negative. There it is, 1.140, and that our right intercept, x-intercept, was at 1.40. And then we were looking for the part of the parabola that was greater than where y was 0. And so those were those branches that went off upwards to the right and to the left. And those branches are just above the x values that are greater than or equal to 1.4 and less than or equal to -1.14. All right, and then on B, we know that when we graph that, well, first we put it in standard form. We found that our x-intercepts were at -2, 0, and 1/2, 0. So we want the x values, the part of the parabola that is less than where y is 0. So we wanted the little dip, and the x values that are above that part of the parabola are the ones that were less than or equal to 1/2 and greater than or equal to -2. Now, when you put the next quadratic on your graphing calculator and then do the steps to find the zeros, the x-intercepts, then you should have found at -1.5, 0, and at 0.2, 0, we had x-intercepts. We want the part of the parabola that is less than where y is 0, so we want those legs that are down underneath that part. And so those legs are below the x values that are greater than 0.2 and less than -1.5. And then finally, writing this one in standard form, we're going to add our 5x over, put that on our graphing calculator, and find our x-intercepts at -2, 0, and at -1/2, 0. And then we're looking for the part of the parabola that is greater than where y is 0, so that will be the legs, those branches that are going upwards and out, which are above the x values that are greater than -1/2 and less than -2. Now let's look at this real-life example. So a rectangular parking lot must have a perimeter of 440 feet and an area of at least 8,000 square feet. Describe the possible lengths of the parking lot. So let's write some equations. 2 times the length plus 2 times the width needs to equal 440. Length times width needs to be greater than or equal to at least 8,000 square feet. So solving for W, We'll subtract our 2L over, and so I'll bring back our original equations. They went away for a moment. And our inequality. And then we need to divide by 2. And so width will equal 220 minus length. So now let's plug in this so we can get this equation in terms of one variable. When I distribute my L, I get 220L minus L squared is greater than or equal to 8,000. And I realize that I can rearrange this and I have a quadratic in standard form. So negative L squared plus 220L minus 8,000 needs to be greater than or equal to 0. Now I want to find those length values that will satisfy that. So you can use your graphing calculator, put that on your graphing calculator, have x be L, so our length will be our input x, and then our width will be y. So what you're looking for then is you want to find those intercepts. So you'll need to adjust your window so you can see that parabola, and then do your second calculate and then number 2 trace. And you'll find that your 2x intercepts are at 49.5 about as 0 and then 174, 0. So we want the part of the parabola that is greater than where y is 0. So we want the x values that are below that curve of the parabola. And so those are the x values that will be less than, and we are using a graphing calculator, but those will be the x, or in this case, the L, the lengths, possible lengths, that are less than or equal to 174 and greater than or equal to 49.5. So our length needs to be at least 46 feet about and less than or equal to 174. So 174 feet at the most. So that's a real life application of solving a quadratic inequality, finding that interval values that meet that situation. All right, this concludes the notes for quadratic inequalities, all sorts of them.